Hello, calculus fans. All right, let's go ahead and make a definition of an improper integral. So there'll be two types of improper integrals. The first type will be the one where we have an infinite interval of integration. So first we'll say that if the integral from a to t of f of x dx exists for every number t bigger than or equal to a, then we're going to define the integral from a to infinity of f of x dx to be the limit as t goes to infinity of a to t of f of x dx. I'm using a t here. Earlier I was using a b. It actually doesn't even really matter what letter you use, just as long as you rewrite your improper integral as a limit. And of course, this limit has to exist, and it has to be a finite number. Now we can do this on the other side. We can, if you have a improper integral because the lower limit is infinity, well, that's okay. Then we can have a limit as t goes to negative infinity of the integral from t to b of f of x dx. And again, provided that this limit exists as a finite number. All right, so we're only going to call these limits existing if they're finite numbers. Now we've talked about how limits can go to infinity. We're not going to want that. Now these improper integrals are called convergent if the corresponding limits exist. And we're going to call them divergent if the limit does not exist. And in the last case, if both these integrals, the integrals from c to infinity of f of x dx and the integral from minus infinity to c of f of x dx, if they're both convergent as separate limits, then we're going to define the integral from minus infinity to infinity of f of x dx to be the sum of these two things. And it doesn't really matter what the number c is. Most often we'll just break these up at 0. You can actually break things up anywhere you like. So this is just the definition of an improper integral. This is a type 1 infinite integral of integration improper integral. Okay, that's all for now.